Hey everybody, today we are going to be going over complementary angles using trigonometric functions. So, the first thing we need to look at is this right triangle here. We need to identify what angles would be complementary to one another. Considering so far we already have y as a 90-degree angle, which two other angles, when added together, their sum would be 90? If you said angle x and angle z, you are correct. Angle x plus angle z would equal 90 degrees. Now, using our understanding of right triangles and this complementary angle theorem, what we're going to have to do is use our trigonometric functions to find sine, cosine, and tangent given those angles. Now, the side lengths are going to be represented by letters A, B, and C. Each fraction that you write for sine, cosine, and tangent should be using those three letters. Now, at this time, take a moment, hit pause, and find the sine, cosine, and tangent of both x and z. All right, continuing, we're going to find the rule of complementary angles using our trigonometric functions. Just remember, so, ka, toa. So in this case here, if you haven't looked at the backboard, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now looking at our right triangle down here, our side lengths are represented by A, B, and C. And what we're going to have to do here is find the sine, cosine, and tangent of the angles x and z. So, using SOHCAHTOA, our sine of x, which our reference point is going to change to here, our sine of x, which is opposite over hypotenuse, would be c over b. Our cosine of x, which is adjacent over hypotenuse, is going to be a over b. And our tangent is going to be opposite over adjacent, which is going to be c over a. All right, moving on. Our angle of reference is going to change from x to z, and we are going to use the exact same approach. So once again, sine is opposite over hypotenuse. So the opposite side of z would be a, and the hypotenuse still remains b. The cosine of z would be adjacent over hypotenuse, which would be c over b, and the tangent, which is opposite over adjacent, which would be a over c. Now, what I'd like you to do is take a look at your sines and cosines of both of these angles. What I'd like you to write down is if you see anything in particular that stands out, that may tell you something specific relating one of the sine, cosines, and tangents of x to the sine, cosine, and tangent of z. Here are the conclusions you should have come to. If you're looking at sine of x right here, which equals c over b, it will equal cosine of z, which would equal c over b. So in this case, x and z are complements of one another, meaning they add up to 90 degrees. So we can say sine of one of our complementary angles is going to equal our cosine of our other complementary angle. Now, it also works the other way. If you look at cosine of x, it's going to equal our sine of z. All right? Sine of x equals cosine of z, and cosine of x equals sine of z. And last but not least, what we should have seen is that our tangents of our two complementary angles are inverses of one another. So the tangent of x, which equals c over a, is an inverse of tangent of z, which equals a over c. All right, so this is a discovery you should have had today. You will continue with your worksheet that I will leave here with the substitute. If you haven't received it just yet, please make sure you get it. Have a great day, everybody.